Hello and welcome to iitiansgateclasses once again. And we are continuing today with linked list. Okay. So we have seen that the user defined data type, which is structure. Okay. And in structure, we can have one data element and one pointer to itself, or you can say pointer to a structure type only. Okay. So here we can define structure like struct, and the name of the structure. Right now we are defining it as a node, an ODE. Okay. And here we are having two types of data. Here you can have character, integer, or float, any type. Right now I'm considering that our data having type integer. Okay. So that's why I defined it as integer, int a, and one pointer to itself, or you can say pointer to a type of struct node. Struct node star. We named it next. This is the name of the variable next. Okay. So if we define structure like this, we can have data structure as linked list. Yesterday we discussed how can we define linked list. You can say that okay, that we have a node, struct node a equal to some value here like 10 comma null, struct node b here as 20 comma null. Okay, so we initializing this variable, this integer. Okay, so this is confusing. I will define this as p. It's p here. Value of this integer is p. The name of this integer is p. Integer variable is p. And here we have a struct node a, struct node b, and struct node c equal to 30 comma null, struct node d equal to 40 comma null. Okay, here the value of integer value is 10 and the pointer we set it to null. So now we have 1, 2, 3, 4 nodes. We have total 4 nodes, and we want to connect these nodes in sequential manner, which is called linked list. How can we do that? We can do it like a equal to, we can do it like a dot next equal to and %b. So you can see here that next is a struct node pointer. The struct node star is saying it's pointer. So that is why we have to save the address of b. And you can say that b dot next equal to address of c, and c dot next equal to address of d. And %d means address of d. Now it will make a linked list like this. 10 here, which is a, and then the next of a we have address of b, which we indicate using array. It is easier to visualize. Okay, 20. In b we have pointer to the c node, 30. Then here we have variable d, which is 40 here, and here we have null. Okay, which is saying that this is end of the linked list. So what do we need in a linked list? We need only pointer to the first variable, okay. So we define linked list as ll. Let's say that we define linked list as ll, and we define it like struct node star ll equal to and %a. That's it. Now you have the whole linked list saved in ll. How come? So if you do ll arrow p is the data variable. Okay, this is the p. So it will give you, if you print this thing, it will give you what, 10. Okay, so we have a pointer ll here which is pointing out to the first node. Okay, ll contains address of first node. Assume that the address of first node is 1000, so it contains 1000 here. Using this pointer address, we can actually iterate, or we can go through the whole linked list. How can we go through the whole linked list? If we do ll pointer next, we have the address of we have the address which we saved here, okay, which we saved here. We have the address of B now. Now, from this address, from this or pointer, you can say, from this address, how can we pull the data? Arrow P. So if you print this thing, it will print 10, sorry, 20. It will print 20. So if you want to print printf ll next P, what it will print? It will print 30 here. It means we are going, this is the first node, we are going to the next node, then next node, and we are printing the data. That's it. So this is how you can iterate the whole linked list. Okay, now let's see some program and see what it will print after the iteration. Okay, so let's see a linked list here. You are given with the linked list LL like this. The address of first node is saved in F. Okay, the first node is A. It contains the character A. Okay, and its start address is 1000. The address of second node is 2000. It contains a character B. Okay, so you can assume that here we are saving 2000 actually, which denotes the next pointer address. Okay, next pointer address, next node address. Okay, so I'm not writing down all the addresses here. Assume that this arrow indicates that we are saving the address of next node here in the next pointer. So we have 3000 is the starting address of this node. Why am I saying starting address? Because the structure have lot of addresses. You can say it contains lot of memory. Why lot of memory? If you go back, it contains 2 bytes and it contains 8 bytes. Okay, this saved in 8 bytes. So it have actually 10 bytes or 10 addresses. That is why I'm saying starting address. Starting address means address of first byte. Okay, similarly C, and then you have D here, E here, F here, G here. Okay, so this is the linked list. The address of D is 2500. The address of E is 3500. The address of F is 500. The address of G is 4000. Okay, these are the addresses given. It is already given that our linked list is like this: A, B, C, D, E, F, G. These are the characters saved in the data. So you can assume that our structure is like this: struct node, single node of this linked list, or you can say structure is like this: character P. Okay, then struct node star next. This is our structure given. Using this structure, we have created this whole linked list. So you can see that the data of each data, or the type of the data of each node is character. That is why we saved A, B, C, D here. Okay. So let's see the question. What do we have to find out? The first thing is, okay, initially there are few steps we are printing or we are performing, and we have to identify what will be the output of this program. Okay, so there are few steps. The first line of the program is define a structure pointer struct node star P. So we defined a pointer of type P. Then we say that in the second line, these are the line number. Okay, in the second line we say that P equal to S next. Okay, so assigned a address. You have to compute the address like this using this pointer structure. You have to compute the address. In the third line, I did S next equal to P next, next, next. Okay. In the fourth line, what I did, I said that P next, next, 4 times next. Okay, next, 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 equal to S next, next. That's it. Yeah. In the fifth line, I print S. How many times next? 7 times next. Okay, 7 times next. Then data. Okay, then data. Okay, whichever node we are going to, we will print the data of it. Okay, 7 times. This next is 7 times. Okay, like this. Next, 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 like this. We are doing this next 7 times. 7 times. Here we did S this arrow next 7 times. Now let's go through this program. Go through this program using some other color, green color. Okay. So once, what will be the address that P will contain? It contains S dot next. S arrow next is 2000, and its again next is 3000. Its next is 2500. So P will contain the address 2500. For the better understanding or simplicity, I labeled these addresses intentionally. Okay, it may not be given, these addresses may not be given to you, so you can label them. So it will be easier to track the addresses. Okay, now it's saying that S arrow next, 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 3 times again, this thing. So we have this node now. Here we have this node. Now we are at this node and we are saying that in the next of it right now, S dot next is this one, this node, and X dot next is this node. In the next of this one, this C, not D, actually it's C, in the next of C, right? What is this node? This node, S dot next is this node, S dot next is this node. Again node, like next, we reach to this node. And we are saying that in the next pointer of this node, save this address, What is this address? P next, next, next. So P is this one. It's next, next, and next. Okay, so it's saying that instead of storing 2500 here, store directly G here, 4000 here, 4000 here. Okay, it's saying that store 4000. Remove this arrow and connect this arrow. Okay, using this line, I am stating this thing. Now it's saying that P next, 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 next. So what is P next, next, next? P is this thing. Okay, it's next, 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 and next is null actually. So its next is null. Right now it's null. Instead of null, it's saying that save S next, next, S next, next, which is 3000. So it's saying that store 3000 here. So it basically it become a loop. It become a loop, right? Now it want to print the data 7 times S max. So if you do 7 times 1, 2, 3, then we go here 4, then again we go here 5, then 6, 7. So we'll print C here. Okay. Again, let me try to print this linked list. This is the linked list A, B, C, D, E, F, and G. Okay. And for better visualization, we have given them addresses like 1000, 2000, 3000, 2500, 3500, 500, and 4000. Now, why did I label them like this? Like after 3000, why did I have given, why did I give this address 2500? Why? Because in linked list, the sequential address are not mandatory. Okay, because we are saving the address of next node here, it could be any address. Okay, it could be 0, it could be 20,000, it could be before this address, after this address, it doesn't really matter. So if this is your memory, okay, and you have addresses like this. These are the addresses as per your data type. Okay, so you can make linked list like this. From this you can go here, from this you can go here, from this you can go here. Okay, that is why the sequential, these are the sequential blocks in the memory. I am represented this as a sequential block, like the real addresses goes like 0, 1, 2, 3, 4, 5, 6, 7, 8. But we made linked list like some random sequence. It means the memory in the next pointer of 8 is of 2. Okay, so it could be of any order. So what are the benefits of the linked list? Benefit of the linked list is we don't require sequential memory like array. Okay, in array we require sequential memory. If this is 1,000 address, this has to be 1,002 or 1,001, depends upon the data type. If it's a character data type, it has to be 1,001. Okay, because we are not saving pointer of 1,001 in the previous data type, previous record, or you can say previous item. So in array, it has to be sequential. So once we define array, the growth of the array, for example, if you define array of 10 size, if you want to increase the size of array from 10 to 11, it may be possible, it may not be possible, because sometimes what happens at the 11th position, maybe you have saved some other variable in the program, you may have saved something else. So you have to reallocate the whole array somewhere else. If you want 11 again, 11th position, if you want to resize the array, it won't be possible until you shift the whole array, existing array of size 10 to another memory. Okay, here if you want to increase the size of this linked list, we can increase it very easily. How come? We can simply look for the blank space. For example, these are the blocks of the memory. If these are the blocks of the memory, sequential blocks. Okay, suppose here you have created an array, okay, of size 4, and here you have defined some integer. Here you have defined some integer. Now you want to initialize a linked list. You can initialize linked list like this, this, then it can go like this, then this, then this. Okay, from here it can go like this. Okay, so basically you can connect any random blocks in the linked list, but the problem for that is for each item you have the data as well as pointer to the next memory. Okay, so this arrow is basically a pointer. I explained yesterday. Okay, you must have the pointer to the next memory, and that pointer is of size 8 byte, which is quite huge because your data is of 2 byte, 4 byte, and your pointer is of 8 bytes. So the all over memory consumption is high, but you can randomly pick any memory, like from 3,500, I am pointing to 500. Okay, it is possible only because of linked list, the structure of the linked list. Now let's move on to our question. This is one concept. So what is the pro, you can say, pro of linked list? You can randomly pick any memory and make a linked list. It doesn't have to be sequential. So you can grow, that will lead to the growth of the linked list or shrink of the linked list. You can deallocate any node. Okay, and you can indicate it through any node. Once you want to add a block, how can you add? The insertion and deletion I will explain later. First, let's see this program. It is given that first we initialize a struct node star p. So we have one pointer here. In the next line, what we did, we say that p equal to s next, and next. What is s? This is s, and we did s next. Next means this is S, its next is this one, its next is this one, next is this one. Okay. So sorry, S next is 2000, its next is 3000, and its next is 2500. Okay, so P is basically 2500. In the next line, we say that in X, next, save this pointer. Currently, it may have any pointer. You will see what it contains. But now assign this pointer from S next, and next. Let's see what it will do. Here S is 1000. S next is 2000 here, and its next is 3000. So we are at 3000. We are at this node. And we are referring to its next pointer. Its next means this pointer, this arrow we are referring. Now it says that broke this arrow. Instead of saving 2000, right now it contains 2500. We are saying that, okay, remove 2500 and save this address. What is this address? P is right now here. Next, which is next, which is 4000. Save 4000 here. Okay, let me clean this mess up. And we are saying instead of 2500, remove this arrow and save in, and basically create a new arrow, which is this arrow. In the next step of the program, it says that let's do P next. Okay, next equal to S next. So in the next of this pointer, this is the pointer we are looking for. What is this pointer? This is P is basically 2500. Its next is 3500. Okay, let me pick another color. And its next is 500, and its next is 4000. So we are at 4000 number node, 4000 address node. In the next of this node, right now it contains null, nothing. It contains null. So remove null and save this pointer here. What is this pointer? This is 1000. This is 2000. Okay, 1000, 2000, and 3000. 3000. Save 3000 here. So remove null and save 3000 here. 3000 here. And using arrows, you can denote it like right now. It will point out to this node. Okay. So this become a loop, right? This become a loop. There is no end point of this linked list right now. There is no end point of this linked list right now. This become a loop. And in the next step, we will try to identify the loop in the linked list. But right now, this will become a loop. Now, what will be the value of S 7 times next data? Okay. So this is 1 time next, 2 time next, 3 time, 4, 5, 6, and 7. Okay. So this is 7 times, and the data of it is G. So previously I was mistaken. I printed as C by mistake, but right now its value is G, right? This is 1 time next, 2 time next, 3, 4, 5, 6, and 7. Okay. So it will print G. I hope you understood the program. Now let's move on to the next program, which says that, okay, let's see some generic program. Right now it's very hard coded, right? You are given some values, some pointers, something like this. Now let's move on to some generic program. After that, we will see how to identify loop in the program. Okay. Now it says that question is write a program to add a node, given node with data x. The data have value x at the end of linked list, given linked list. Assume a linked list. So you need to write first. Let's assume a linked list: A, B, C, D, E. Right. So this is the linked list, and we have null here. Now, what do we want? Our and is we want to insert a node here at the end, and instead of null, we want to save it here and null here. Okay, this will be the last node. We want this. Add a node with data x at the end of the linked list. If this is the linked list, we want to insert this node at the end. Okay, how can we do that? First, we will create the node. Then we will iterate through the linked list, reach to the end node, and assign this node to the end node. Okay, what will our steps is create a node, or you can say structure variable with value x. Second thing is iterate over given linked list, reach to the last node. Because in linked list, we are given with the starting pointer only. Okay, I've explained like only the starting pointer is enough. That is why they gave you only starting pointer. And we have to reach to the last node. Then at the last node, insert the newly created node. Okay, newly created node. Okay, these three steps we will perform. Now, using all these three steps, it will clear some concepts for you. Okay, so how can we create like initialize, create and initialize a node? Struct node star p. So this is the node that we want to create. Right now, this node contains nothing, null. It contains null, nothing. Okay, nothing. Null means nothing. There is no memory allocated to this node. This node contains no memory at all. How can we initialize the memory? We say that p equal to struct node star. This is the type of this node. Okay, this is the type of memory we want. Type of memory we want. Okay, then you say that Mellow. I will tell you what is Mellow and Mellow. Mellow, and then how much memory we want. Size of struct node. This much memory we want. Okay, this much memory we want. Assume that our data pointer is of 1 byte and our data pointer is of 8 bytes and data is of 1 byte. So it will give us 9 bytes. Depend upon the size of struct node. If our struct node is something like this, struct node character data, then we have here struct node star next. Okay, So how much? It's 1 byte. It's 8 bytes. So it's total 9 byte. Now this malloc function, what it will do? This malloc function, it's very important. It will give you address to this. It will basically create a 9 byte memory. How it will create 9 byte memory? It will see the size of this node. See, I have used a function size of. Okay, size of struct node. Size of struct node is 9 byte. So it will create, or you can say it will pick a 9 byte out of your memory, and it will give you starting address of this 9 byte. Okay, starting address of this much size of struct node, 9 bytes here. Here it's 9 bytes, it may vary. Starting address of this 9 byte, it will allocate the 9 byte memory. Okay, and it give you starting address of the 9 byte, this malloc function. Now the address has to be is of a type. Okay, the address has to be address has to have a type. Okay, we assign the type like struct node star. It will give you the address, then it will typecast into struct node type, because our pointer contains struct node star. So we have to typecast it. So you have typecasted this address. Okay, let's go one by one. What did I write? I write p equal to struct node star malloc size of struct node. Okay, this is what I have written. So the operation will be performed like this. Size of struct node will return the memory that each structure of type node can contain. It is 9 byte here. Here it's 9 byte. Somewhere it could be 10 byte, 12 byte, 11 byte. We don't know. So okay, it's 9 byte here. So this malloc function allocate this memory, 9 byte memory somewhere, and it will return the starting address of this 9 bytes. Okay, this will return that address. Now this address has to be of some type, because we want to save it in P. So programming language asks you some type. So we did typecasting here. It's typecasting of address. Okay, so once you typecast it, you will have the address. Okay, now this is the first step we did, and it cleared what is a malloc function. Malloc function is very important function for you. Right now in Python and other programming language, they allocate memory by itself. Okay, you don't have to allocate memory, but in the previous languages like C, C++, which are currently being used at various platforms, like to create a driver, to create an operating system, you have to allocate your own memory. And this is also kind of memory optimization also we are doing in the program. So in the next step, we assign it. So right now it will create a memory of size P. Okay, like this, 9 byte. Now you say that, okay, P arrow data. Okay, remember our structure is of type like this. This is our structure. This is our struct node. So we do P arrow data to save the data. Here we will say that, okay, let's save X here. And P arrow next equal to null. Now the next pointer contains null, nothing. Okay. And you are given, so we did 2 steps. First step is this one. So we did only 1 step till here. We created first step here only. We created a node with value X. Okay, right now we stored the value also in the node. Stored store stored the value x in newly created node. Okay, right now we stored the value. Now let's move on to the second step, where we have to iterate for the linked list. Right now, struct node star s. This s contains basically starting address of the linked list, or you can say first node address. Okay, so you cannot lose first node address. That is why you have to create a temporary variable to iterate. If you iterate this node, you will lose this first node address. You cannot lose first node address. Okay, that is why you have to create a temporary node of type struct node star s1. This s1, in this s1, we will basically initialize. We will initialize this s1 with s. Now we will not iterate s. Okay, suppose this is our linked list, and here this s is pointing out to the first node. It should always point out to the first node only. If you point out s to some c, you lose these addresses. There is no pointing back. Okay, that is why you have to create temporary variable always, s1. Okay, now let's iterate s. You say that while s1 hyphen next not equal to null, I will iterate it. I will say s1 equal to s1. Okay. Using this while loop, I iterated s1. What I'm saying that till the next of s1 is not null, assign s1 to the s1 next. Okay, how it will go? It will go like this. Okay, let me create a linked list here. Let me create a linked list. The same linked list A, B, C, D, and E. Right now, S is pointing out to this one, and we initialize S1 also like this. Now we are saying that its next is not null. It's not null, right? In the next, we have the address of B. So do S1 equal to S1 hyphen next. Do this, okay? So S1 will go here. Again, its next is not null. It will go here. Okay. Again, its next is not null. It will go here. Again, its next is not null. It will go here. Now its next is null. It's null. This condition is break. It's satisfied, right? So it is not satisfied. So it will break the while loop. We have reached to the last node. Using this very two simple lines, we have reached to the last node. Once we reach to the last node, what we will do? We will do that out of this while loop. Out of this while loop, we will do S1 next equal to P. That's it. So there is a node P. There is a node P, and we assigned P like this. Okay, we assigned P like this, X and null here. Okay, that is how first we created a memory, blank memory like this, 9 bytes. Then we did X here and null here. Using these two lines, we initialize P, and in P is like X null. This is P. Now it's saying that S1 arrow next assign P, and our program is completed. Now let's write down the program in a very single page. It will go like struct node star P equal to struct node star Mellow, which is a very important function. Size of struct node. Okay, then we do P arrow data. So this is like assigning P a blank memory. a blank memory. Okay, this is assigning P a blank memory. P data equal to X and P next equal to null. This is initialization of P. Initialization means in the blank memory we are filling something. Then we do that struct node star S1. So we created a temporary variable S1 in which we assigned value S. It is already given that S contains first node. It is already given first node address. We cannot iterate over S because we will lose the previous addresses. Okay, so that is the case. When we do while S1 hyphen next not equal to null, do S1 arrow next, sorry, S1 equal to S1 arrow next. Once it's done, I'm writing the further program here. Once it's done, do S1 next equal to P, and we are done. Now this program may fail. Why? Because what if there is no node in the linked list? Our linked list is null. Our linked list is null. So here you can pause and try to guess like what do we need to write? What is it that we are missing? So here after this thing here in between these two red lines, we need to write this. If S1 is equal null, there is no node. This will be our first node. Just do S equal to P. S equal to P, right? That's it. If that is the case, if this is the case, do this and return from here. Return from here. Else go to this while loop and this thing. I hope it is clear. Now let's move on to very basic concept that what is Mellow function. I already explained what is Mellow. To assign specific, very specific size memory in heap area. So in every compiler, or you can say for every program in memory, we have a program area, like where the program is written, the text of program file, you can say. Then we initialize variable in each program, right? Variables, we create linked list, we allocate something that is called heap area, right? And we also have stacks. Stacks are for function calls, recursive function calls or something like that, right? This I will cover in programming part. Okay, what is heap area, what is stack area? So that is why I'm writing Mellow will assign some memory in the heap area. And calloc, what will the calloc do? Calloc allocate with clear default value. So calloc will also not only assign, it will assign specific size memory and assign default values. For example, if it's assigning an integer value, okay, like you do calloc size of int. So it will create an integer memory and it will assign it a value 0 by default. For each kind of type, it will assign, for example, for float, it will assign 0.0, something like this, okay? So that is the difference. Mellow will assign specific size memory and calloc will assign specific size memory as well as assign a default value also. Okay. Now let's move on to the next thing, next program. What is your like professor asked you to write a program to insert a node insert a node in linked list. He only asked you to insert a node in the linked list. So generally, whenever we insert a node in the linked list, we insert at the first position. So right now here you see that we have iterated the whole linked list and it have taken order of n times. If the size of the current linked list is n, it will iterate n times, okay, n times. So it is order of n. So if somebody asks you that insert a node into the linked list, the easiest way is, here is the linked list, S, A, B, C, D, E, something like this, okay, and it's null here. Now you have a new node X, you created new node XP. What you will do, you will say that, okay, I have created new node P. Till here the program will be same. Till here the program will be same, okay. You just have created and initialized a new node, After that, what you will do, this node you will write like this, okay, that P dot next equal to S and S equal to P. That's it. So these are just two lines and some few lines here. So it is basically constant time. You haven't done any iteration. So it is order of 1. What it will do, this P hyphen next. Initially, once we assign next, it is null here. Right? Here it's null. Then we do P arrow next equal to S. So it will point out to S. Then we say that, okay, S equal to P. Here, assign this S to here. So now our linked list will look like this. X, A, B, C, D, E. See how easy it is right now. Using only after initialization of this P, creation and initialization of P, we just did 2 lines and it is our new linked list. So insertion of the node at the beginning will take order of 1. Insertion of the node at the end will take order of n. So always try to insert at the first position of the linked list. So once you create the linked list, each time you will insert E first, then D, then C, then B, then A, then X. This is how in each insertion, it will take only order of 1. Because you are inserting at the first position using only these 2 lines. Next is, we want to insert the node at some specific location. Like it is given that insert the node with some value X after C, after C value node, right? And it is given that, okay, C is present in linked list. It is also given that C is present in the linked list. You have to insert the node after C, and C is present in the linked list. So how would you do it? First, you will do these steps again. Creation of the new node. Okay, these 1, 2, 3, and 4 lines you have to do it again. Okay, these 4 lines. Once you have a node P which contains X and null, you will iterate till what? Till you find a node which contains value C. Okay, you will do while in S1 you initialize S1 equal to S. You say that S1 if and data equal while this is not equal to S1 hyphen data is not equal to C. Till that you have to iterate. So you will do S1 equal to S1 next. And if it's not given that C is present in the linked list, so C may be absent. So you have to check that you don't reach to the last node. After last node, you don't reach to the null. So you have to check and S1 next not equal to null. Using this condition, you are saying that I have iterated from beginning till the node which contains C. Okay, so I haven't reached till C yet. Using this condition, you are saying that I haven't reached to C yet. And using this condition, you are saying that I haven't reached to the last node yet. Okay, so this is the while loop. Once you iterate through this while loop, you need to check one thing. You need to check if S1 hyphen data is equal C. It means that I haven't reached to the last node, or maybe if I reach to the last node is C. Whichever node I am at right now, S1 is at right now, its value is C. So I will do S1. We have to insert after S1. Okay. So what I will do, this is the case. Here we have C. Right now S1 is at C. Okay. Now we need to insert a value with node P here. So in the next of P, we will assign this value. And in the next of C, we will assign this value. Right? Like this is how we can insert P here. Okay. So S1 is at node which contains value C. So in the next of P, you will assign S1 next. And in the next of S1, you will assign P. Why can't we perform this section first? If we perform this section first, what will happen? Okay, this is C. This is some other node. This is S1. If we do S1 next, this is P. Okay, this is P. S1 next, which contains X, equal to P. So we will assign this to this one. We have inserted P after S1. But what happened to this this linked list, remaining linked list? We lost this pointer. We lost this pointer to this node. Okay. So that is why first you have to assign the next of P to this one, then you can only assign this one to this. So that is why this should be the order. This is how you can iterate over the linked list, and this is how you can insert a node after a specific location. Okay. So that is it for today. Thank you all for joining. We will see some more linked list programming related questions. There are so many of it, and it will be better for you, and you will have a better understanding of it, because after getting linked list then only you can understand binary tree implementation, binary search tree implementation, and we can like dive into the programming of that also. Okay, thank you all for joining.